Hello Year 4, here is session 4 of our inquiry, and for this session we're going to look at electrical conductors and insulators. And the walk for this session is to be able to identify and sort materials into electrical conductors or insulators. And hopefully by the end you'll be able to explain why some materials conduct electrical currents and why others don't. So, insulators and conductors. In most materials, the atoms look like this. The protons and neutrons, that's the bits in the middle, are attracted to each other as the result of the strong nuclear force, and they form the nucleus of an atom. Now the electrons are attracted to the protons, but this attraction is not as strong as the strong nuclear force which makes the protons and neutrons stick together. Instead, the attraction means that the electrons orbit the protons in the nucleus, a bit like the moon orbits the Earth. Now the electrons cannot move freely in these materials, and so no electric current can be produced. So the electrons can do nothing but orbit the protons in the middle of the atom. So these materials are electrical insulators. And if you create a circuit which includes an electrical insulator, it will be incomplete, even if it looks complete, as no electrons will flow through the material. But in some materials, some of the electrons are free electrons, and these can move. And if you create a circuit with these materials, the free electrons can be made to move in one direction, and that's what creates the electric current. And these materials are called electrical conductors. But note, if the circuit hasn't been set up correctly, then the electric current cannot flow even through a conductor. So you still need to have a complete circuit. I'm going to test the materials on your behalf. Obviously, if we were in school, I'd get the equipment out and you'd be able to have a go yourself. So I'm going to create a circuit that looks like this, and then I'm going to put objects between the two open crocodile clips, and we'll test whether or not they are conductors. So if the bulb lights on the circuit, then the material is an electrical conductor. If the bulb remains unlit, the material is an electrical insulator. So here are the materials I'm going to test. If you've downloaded the worksheet, then you'll have that list of materials. And at this point, I'd like you to fill in the prediction section of the worksheet to say whether or not the material is a conductor or an insulator. If you haven't downloaded the worksheet, then you could write this list on a piece of paper before you carry on, and then you can make your predictions. Now, there is one item missing from the list. I'd like you to think about what that could be, and when you know, write it in the empty cell and then tick whether it's an insulator or a conductor. And then when you're ready, continue the video and have a look at my results from testing. hopefully now you can identify which materials are electrical conductors and which materials are insulators, and you can sort them accordingly. Hopefully you can also explain why they conduct electrical currents, but don't worry too much if you can't remember the scientific explanation completely. And here's the results. So we should have found that the cloth, the Lego, the lolly stick, the wool, the pencil, Piglet, the lettuce leaf, the sponge, the glass jar, the screwdriver and the paper did not conduct electricity. They are all insulators. Whereas the coin, the copper, the bottle top and the paperclip did conduct electricity. So they are conductors. Wonder, can you see something that they all share, something they have in common? And then finally, the missing item was air, which is an insulator. And we know this because when there is a gap in the circuit, the bulb does not light.